exist, and 2, is the limit continuous? So if it exists, it has to have these three things being true, and we'll do an example with that. And if it's continuous, it has to have these three things being true. Okay, and we'll do an example so that you can see that. And there we go. So what we're trying to do, there's two things to this question. Yes, we have a part A and a B. The first part is that we have to state whether the limit exists. If not, explain why. And you're going to do this using a graph. And then the second part is to write whether what the limit n behavior would be in a limit form. So, for the first one, part A, can we graph this? Is it possible to graph this? However, if we look at this, there is actually a variable. This is our final function, and our x variable, or independent variable, is n. So, if we were to graph this, add a page. For 1, this would be our n, and this is 3 to the n minus 2. And if you look at those coordinates, when n is 1, if we substitute n as 1 here, that gives us 3 to the power of 1 minus 2, which is 3 to the power of negative 1, which is 1/3. And so you're going along, n is 2, n is 3, n is 4, to graph that. Yes? We have to say, does this limit exist? What it means for a limit to exist is, does this go to one value? Is it approaching one thing? So if as our n value is getting larger and larger and larger, is this going to go to one value? That means that this function is called diverge. This function diverges, which means it approaches infinity. This also means then that the limit does not exist. So I can put that below. Does not exist is the short form that you'll most likely. Not that way is for the limit. What's our x variable doing? What's our x variable doing? As we said, it diverged. Increasing to it. Good. So as x approaches infinity, is it x in this case though? Perfect. So as n goes to infinity of our function, did we give it a variable? Our function was 3 to the n minus 2. What did you say it diverged to? Infinity. So that's what the notation would be for that one. So if we're coming from the left, we're going this way. If we're coming from the right, we're going this way. And you don't need the arrow, just to show you which direction you're coming from. Now the whole part is part C. So at x equals 4, what are we approaching? To be able to tell what the limit is at x approaching to 4, you have to see if these two are equal. Do they equal the same value? Yes? So this does exist, and it exists at -1, just as the other ones. That is only true if both part A and B are the same number. So for example, this was 1 and this was -2, whatever, they're different numbers, this cannot exist. So what would f of 4 be? It would be -1. Okay, yep. So we determine these values, and just as a side note, let's try and look back at our criteria. So criteria for existing. Did our value from the left exist? Yes, it did. Did our value from the right exist? Yes, it did. Did the two things equal? Yes. So does the limit exist? Yes, it does. So that's, yeah, we're good. The limit exists. Okay, let's look at the continuity. If we look at our continuity, did f of a exist, or f of 4? Yeah, it was -1. Did f of the limit as x goes to a exist? Yes. Did the two things equal? So this function is continuous. If we go back to here, the other way that you can tell continuity is if you can put your pen on the page and not lift it from the page and get from one end of the function to the other end of the function, that is continuous. So if you went here, you went all the way along, did I have to take the pen off at all? No, so it's continuous. What if we put an open dot there? You have to come along here, then you'd have to lift up because you can't equal it, and then you'd have to continue on. So that's right. This is discontinuous. But is this still a limit? So what is a piecewise function? A piecewise function is a combination of a bunch of functions, whether that be lines and parabolas. It can be a combination of any type of function. But it's only looking at functions between certain intervals. So this is a situation where we have these different functions, and then someone's asking, is it possible for the limit not to exist? So here's a situation where the limit does not exist. Yay! So we can go from our y-intercept of 2, and we can go down 2, over 1, down 2, over 1. Yes? And we could keep going. We could draw a line from end to end. Why will we not draw a full line from quadrant 2 to quadrant 4? We can only be between 0 and 2. So if we look here, okay, perfect. Our y-intercept started at a time of 0, and then we went here to t at 2. So there's your line. Can we equal both endpoints, 0 and 2? Yes, so it's a filled-in dot. So now we're going to graph the next part. What type of function is this? Quadratic. And this is actually in vertex form. What's our vertex? 2, yeah, positive 2, comma, 0. So if we were to put that here, positive 2, comma, 0 is our vertex. Can we equal at 2 though? No, why not? It's a circle bracket. So yes, we can be here like this. And then do we know if we open up or down? We open up because this value in front here is a positive 1, which is positive, which means we open up. So we could do step pattern, use a table of values to graph the rest of this parabola. However, what do we not want from this parabola? So for the first part, guys, we are trying to get at x equals 2 with a little negative from the left. So when you come on the graph and you come from the left, what's the first function you come to? The line or the parabola? Okay, so jump onto the line and you come down. As you come to 2, what are you approaching? You're approaching negative 2. Now if we're going to come at x equals 2, you're going to come from the right. So if you start coming from the right, what's the first function you come to? So jump on. What are you approaching? You're approaching 0. So the last part for the limit, x approaching 2, the whole thing, that means from the left and from the right, do they equal? No. So the limit does not exist.